Hello guys, I am Shashikan Hangare and today I am going to demonstrate how to program any ATMEL microcontroller with the Arduino IDE. So ATMEL and Arduino. So ATMEL, as many of you will be knowing, that ATMEL is a company which produces microcontroller for various applications. So according to your application, you can use the ATMEL series, ATMEGA series microcontrollers like the ATMEGA 16, ATMEGA 8, ATMEGA 32, ATMEGA 2560, and the second company is Arduino. So Arduino is a actually organization which make their boards, the development boards on the ATMEL microcontrollers. So and you can program this control development boards using the Arduino IDE. So uh, the question is, can we program any even microcontroller with the Arduino IDE? Yeah, the answer is yes. But how and why? So let's first see how. But first, let's see why. So many of people means most of the people, you have written the programming embedded C. So as you can see, this is a buzzer beep program where the buzzer is on for 1 second and off for another second. And as you can see, as a typical C program, same like embedded C, which is superset of C. Uh, First, we have to initialize all the include files, then define the functions, and then call the functions. And also we have used too many hexadecimal code. So this type code of code is quite lengthy, and also you can see that this code is not quite easy to digest. Means uh, usage of so many hexadecimal codes and uh, means this type of functions like the port restore is not quite common and is not quite understandable to the people who are just enthusiasts to make their projects, but they don't want to use embedded C. So the same. So what is the another option to write the program in then Arduino? So as you can see, this is the buzzer program in the Arduino. As and as you know, there is no means we have not used any uh, hexadecimal codes. Only the functions digital write, which we know, which we can understand from the name that it is used to digital write the pins. And also we have used the functions like pin mode. So as you can see, the code is quite small, only 16 lines, and uh, this and the code is quite understandable. So you have two benefits. Writing the code in Arduino, writing the code in Arduino, you can understand the code quite easily, and second, you can reduce the number of lines of code. So the mission is accomplished. But there is a problem. What is the problem? That the boards enlisted in the Arduino IDE are uses too few ATMEGA microcontrollers. The most common ATMEGA microcontroller is the ATMEGA 8 microcontroller, which has which are two forms, ATMEGA 3 to ATMEGA 168, and the other Arduino microcontroller which people uses is the Arduino Mega, ATMEGA 2560. So only two microcontrollers, ATMEGA 2 or 3 microcontrollers you can use to program, means two microcontrollers can be programmed using Arduino IDE. So for this, as you have seen, for this now, how what to do. So now we come to second part, that is how do we program a microcontroller which is not listed in the this Arduino board section using the Arduino IDE. So first of all, the materials will be requiring a PC, which is quite common, a PC with the Arduino IDE 1.0.x, means 1.0.1, 1.0.2, 1.0.5, and the AVR ATMEL should be installed with, and also WinAVR installed, which provides the AVR DUT and AVR GCC functionality. And the second is AVR ISP MK2 programmer or any other USB programmer. Uh, and I will be showing the images right after this slide. In ATMEGA 8, ATMEGA 16, ATMEGA 32, or ATMEGA 2560 microcontroller. So I will be using ATMEGA 16 microcontroller for the demonstration. LED or a buzzer. I will be having a buzzer and Arduino extra core files. So the link with for Arduino IDE, ATMEL Studio, WinAVR, and Arduino extra course is provided in the description. So you can download it from there. And so these are the hardware parts I'll be using for programming the microcontroller. So this AVR ISP MK2 programmer, which is used to flash programs on the ATMEGA 16 board, and this is a robot which has a buzzer installed in it, and this is Sparky robot, which is given by the Next Robotics to our Yantra lab, and we can it has a ATMEGA 16 microcontroller installed in it. So So we can now so we have all the parts, hardware part, and now we'll proceed to the software part. So before going proceed to software part, let's just see how the Arduino code is compiled and burned onto the microcontroller. So this is the image. So as you can see the inside story as I have written, first of all we write the code in the Arduino editor. Then the code, when we hit the button, this button verify, means it is just like compiling the code or building the code in the ATMEL studio or AVR studio. So when when we hit the button verify, the code is given to the AVR compiler, which compiles it and converts into the machine readable instructions or object files, as we call it in the C lingo. And these object files are given to the linker, which links the Arduino libraries to it and is converted to the bytecode, which is in the form of Intel hex code. So so finally the target is to make hex file. So this hex file is then given to the AVR dude, which flash the program to the flash memory of the microcontrollers. And here instead of buzzer I used LED. So which can also be a buzzer. So LED goes for once on for 1 second, off for 1 second. So now we'll move to the we'll move further. So as I have given the links in description, download all the files and install all the things. Install the ATMEL Studio, install the Win AVR. I have already installed them, and I have also downloaded this Arduino 1.0.6 and Arduino extra core files. So I have extracted also them. So just copy this Arduino extra core files into the Arduino hardware in the hardware folder. Now open the Arduino. Now just go to the board menu, and now you can see the ATMEGA 16. So mission is accomplished. We have now added the ATMEGA 16 microcontroller into the Arduino boards menu. So as I have already written the code for buzzer, I will just open it, and instead of clicking on the upload button, just click on verify. So now the process happens. The code is going to the AVR GCC. AVR GCC converts into the object files. Object files is then is linked with the Arduino libraries, and the hex file is created. So how? So basically the final goal is to get the hex files. So as in ATMEL Studio, what happens? As you can see, if we build the code, build solution as so the win AVR GCC is called, it is then compiled, and every process, the process I explained same happens. And uh, if you go to the section, you can go to default, and you can see there is a hex file. So actually we need this hex file to burn into the microcontroller, because it contains the hexadecimal code which the microcontroller understand. Uh, in the same way, Arduino also builds it hex file. So where to find this hex file? Just uh, just go to the menu, this start button, and type run, and type this command #temp. So uh, sort the this main it is already sorted by name, so sort this by date modified, so that we can get the latest build file. So build file, in the build file you can see this is a hex buzzer.cpp.hex file. So this is actually the hex file build, which is converted by the AVR GCC when we compile the Arduino code. So just copy it to the desktop. I copied the desktop, and now go to the ATMEL Studio, build, uh, go to the ATMEL Studio and go to tools, go to device programming. So uh, I I will be not able to show you this, but I have using the AVR IC microcontroller, which have connected to the uh, computer through UART cable, and now the control is connected, and the drivers are installed. So from the tool I can see that it is IVR as my MK2. Now the device, so we will be using ATMEGA 16. So just go up and select ATMEGA 16, and as I am using the Sparky robot, so I have connected the 6-pin ISP to the Spark Weave robot, and I have on. So now I can, I applied, so it is having home upgrade. So the MK2 driver was upgraded, means firmware was upgraded. Now I want to read the device signature. So device signature is readed. So this Sparky robot is having the ATMEGA 16. Now just go to memories, and now we'll bring the hex file which is located on the desktop. So buzzer.cvp.hex, and click program. So as you can hear, it has started to beep. So uh, as also now, so now we have accomplished what we required, and thank you for watching this video. Goodbye.